In my last video, we discussed graphing linear inequalities with two variables. So I want to build on that and work through a couple of word problems. So number one, a printing company must hire new employees at their Philadelphia and Boston locations. Okay, the company must hire a total of at least 240 new employees to these two locations to keep up with demand. Express the relationship as an inequality. And then we want to graph this inequality. Okay, so the key word here in the problem, or the key words here in the problem that tell us it's an inequality is at least. So at least 240 means 240 or more. Okay, but we're going to sort of structure this inequality in the same way that we would set up an equation. First thing we're going to do is identify what's unknown and represent them with symbols or variables. So what don't we know? Well, we don't know how many new employees are going to Philly, and we don't know how many new employees are going to Boston. So let's say X equals the number of employees in Philly, and let's say Y could equal or represent the number of employees in Boston. I don't mean total employees, I mean the number hired for Philly and the number hired for Boston. Okay, so what if the words at least weren't there? What if the problem said a total of 240? Well, if we wanted a total of exactly 240, then the number of employees hired in Philly plus the number of employees hired in Boston must be equal to a total of 240. But that's not what we have. We have a total of at least 240. So that means 240 or more. So the number of employees hired, X plus Y, the number of people hired in Philly plus the number of people hired in Boston must be equal to 240 or more. So that's greater than or equal to 240. So in this case, this would be our inequality. X plus Y is greater than or equal to 240. Okay, so now what we want to do is graph this inequality. So the way we've been graphing inequalities is to graph the line first, graph the equation, and then shade accordingly, either shade above or below. Well, we could graph this one by using the intercepts. So previously I was solving for y and using the slope, which we could do also. And we could say x plus y equals 240. Subtract x from both sides. We'll have y equals negative x plus 240. So the slope is negative 1 over 1, and the y-intercept is the point 0, 240. So 240 looks like 200, 210, 220, 230, 240. It looks like it's right about there. And the slope is negative 1, so down 1 over 1. I know those 2 points are really close together, but if we follow that line, we can extend it all the way. Now you'll notice I only have quadrant 1 listed or given here in this graph. You don't see the full 4 quadrants. And the reason being is because X represents a number of people. So if we look at the graph, if we look at quadrants 1, 2, 3, and 4, well, so this part of the x-axis is negative, so that's out. You can't have a negative number of people going to Philly, so we can't have quadrant 2 or quadrant 4. And then this part of the y-axis is negative. You can't have a negative number of people going to Boston, so quadrants 3 and 4 are out. So the only one that makes sense is when x is positive, because that's a number of people going to Philly, and y is positive, number of people going to Boston, which is why we only have quadrant 1. And now, since we're not graphing the equation, we're graphing the inequality. So we graph the or equal to part, but we still need the greater than part, and the greater than part means we shade above. So any point up here, like for example, here's a point. That's 150 for the x value, 200 for the y value. So that would be a total of 350 people. That works. So it needs to be 240 or more. Okay, so that about does it for this problem. Just like with word problems dealing with equations, the first phase of the problem is the setup. And then once we've set up our equation or our inequality, it's really no longer a word problem. All right, so let's look at number 2. Kendra has a maximum of $1,500 to purchase stocks. She wanted to buy some shares of General Electric and some shares of Ford. General Electric was selling at $16 for each share, and Ford for about $12 for each share. So write an inequality that expresses the quantity of each stock that she could buy. Okay, so she's buying some shares of Ford. We don't know how many. And some shares of GE. We don't know how many. So let's say X equal the number of GE shares, and Y equals the number of Ford shares. Okay, so those are the things we don't know. Now, what about this problem tells us it's an inequality? Well, it's that first sentence. Kendra has a maximum of $1,500 to purchase stocks. So she could spend up to $1,500. So we could say the amount that Kendra spends, it could be equal to $1,500. She could spend the whole $1,500, or she could spend less. But she has a maximum of $1,500. She cannot go over $1,500. So the amount she spends has to be either less than or equal to $1,500. All right, so now let's try to set up this inequality. Well, how much does she spend? Well, she spends some money, so we could sort of go step by step in terms of our logic. The money on GE plus the money spent on Ford has to be less than or equal to $1,500. Now, I wouldn't expect you to maybe write everything that I'm writing if you're working out the problem, but I'm just adding as much detail as I can to sort of show you visually the way I'm thinking about this problem. Okay, so the money spent on GE. Well, how much does she spend on GE? Well, you're told in the problem, General Electric was $16 per share of GE plus $12 per share of Ford. That has to be less than or equal to 1,500. Well, how many shares of GE? How many times is she paying $16? Well, we don't know. We're saying there's X of those, X shares of GE. So she's paying $16 for every share, so $16 times X. And then for Ford, we don't know how many she's buying, but we know it's a number. We're calling that Y. So Y shares of Ford. So $12 for each one. That would be 12 times Y is less than or equal to 1,500. All right, so now we want to graph this inequality. So that works for our inequality for her number of shares she could buy. So now let's graph this. Now I'm going to graph. All right, so how do we graph a line? What do we need? Well, we need 2 points. Once we have 2 points, we can draw the line and do the shading. So to graph a line, and we've talked about 2 ways of doing this. Option 1, put the equation in y equals mx plus b form, and then start with the y-intercept. That's point number 1. Then use the slope to find another point. Okay, so that's what we've been doing most of the time. So solve for y equals mx plus b, start with the b, which is a point on the y-axis, and then use the slope to get the second point. Well, point number 2, or option number 2 is find the x-intercept. That's a point on the x-axis. And find the y-intercept. That's a point on the y-axis. That's also going to give you 2 points. Okay, so I'm going to use this method. I'm going to use the intercept method, where basically plug in 0 for x and figure out the y, and plug in 0 for y to figure out the x. So if we have the equation 16x plus 12y equals 1,500. Well, 16 times 0 plus 12 times y equals 1,500. So if we plug in 0 for x and solve for y, that'll give us 1 point. So 12y equals 1,500, and divide both sides by 12. Divide by 12. You'll get y is equal to, and if we do 1,500 divided by 12, we should get 125. So that's 1 point. If we plug in 0 for x, we get 125 for y. So that's that point right there. 125 on the y-axis. And then we're running out of room here, so let's come up over in this area. So now let's do the same thing. We have 16x plus 12y equals 1500. So now let's plug in 0 for y and solve for x. So just do the opposite. 16 times x plus 12 times 0 equals 1500. So 16 times x equals 1500. Divide both sides by 16. And we will get x is equal to, well, if you plug in 1500 divided by 16 into the calculator, you'll get 93.75. Okay, so that's the other intercept. When x is 93.75, y is 0. And so 93.75 on the x-axis, it looks like it's somewhere around there, between 90 and 100. All right, so there's our 2 points. We could have done this using slope as well. I just wanted to sort of show both methods on this worksheet. And so once we have those 2 points, we have our line. And again, we're only looking at the first quadrant where x is positive and y is positive because we can't buy a negative number of stocks or negative number of shares. And since we're not graphing the line, we're graphing the inequality. Here we have less than or equal to. So in this case, less than means below, so we shade below the line. So any point on the line, that's where she's spending all $1,500. That's the equal to 1,500. And any point below the line, that's where she's spending less than 1,500. Okay, I know I went through this, kind of slowly, but again, I was adding a lot of detail and doing a bit more writing than you would do if you were just solving the problem. But these are the kind of problems that you may see on the upcoming final exam. So the methods we used here in this video are important, as they could be applied to other problems. And also, I just want to make sure you notice the similarities between the graphing the inequalities and graphing the equations. Okay, hope this was helpful.